find the critical numbers of f of x equals x to the fourth and use the second derivative test to determine which give local maximum or minimum values. So to find the critical numbers, we need to look at the first derivative, and the first derivative of x to the fourth is 4x cubed. Now, this is never undefined, so the critical number is going to happen when it equals 0. And so we've got 4x cubed equals 0. We divide by 4, giving us x cubed equals 0. And we know that the only number we can cube to get 0 is 0. We can take the cube root of both sides. So the critical number is 0. And then we were asked to use the second derivative test to determine which critical numbers give local maximum or minimum values. So we need the second derivative, which is just the derivative of the first derivative. The derivative of 4x cubed is 12x squared. And we need to evaluate this at our critical number. Well, the second derivative at 0 is going to be 12 times 0 squared, which is just 0. And if you'll recall, this does not tell us anything about whether this critical number is a local maximum, a local minimum, or neither. Unfortunately, at this point, the second derivative test fails to give us any information. And the only thing we can really do is we can use the first derivative test to get an idea of what's going on here. So for the first derivative test, we need to plot our critical numbers on the number line, which is just 0. And we need to put our factors out front for the first derivative, but that's just 4x cubed. And we know that that's going to be positive when x is positive and negative when x is negative. So our first derivative is going to be negative and then positive, which means the function is decreasing and then increasing. And that tells us we have a local minimum. And so the second derivative test didn't tell us anything. The second derivative test failed, but the first derivative test tells us that we have a local minimum at x equals 0. So this is just an important example that shows that the second derivative test might fail, but that doesn't mean there's not necessarily a maximum or minimum. There can still be a maximum or minimum, and we have to use the first derivative test to figure that out. And in this case, we saw very clearly there is a local minimum there. So if the second derivative test fails, don't just give up. You've got to go and do the first derivative test then.